Hello and welcome. Let's solve another question on shear force and bending moment. This question is from GATE. All right. So let's solve this. So for us to solve this question, this is the diagram. This is the exact way they draw the diagram for us. All right. So the first thing we'll be doing is this. We are going to be calculating the reaction at the support, ROB and what? ROE. And then we are going to be starting with the summation of upward forces. By saying the summation of upward force will be equals to what? Y. All right. So, and here we are using upward force to be positive and downward force to be what? Negative. So it means that RB, R subscript B plus R subscript E then will be equals to what? Will be equals to the upward force is 40 plus 50. All right. And don't forget that this is a uniform distributed load which will be converted to a point load. So if we do that, 20 multiplied by what? It's going to be 20 multiplied by 0.5. 20 multiplied by 0.5, and it's going to act at what? At half of the center. That is half of this line. All right. So now, if we do this together, we are going to have RB plus ROE to be equals to 100. So this will be our equation what? 1. All right. So we are going to take moment about point what? We are going to take moment about A, that is the summation of moment about B rather, will be equals to what? 0. All right. So let's take the moment about this point. All right. So we are going to say ROE multiplied by the total distance. Don't forget, upward force is positive, downward force is still what? Negative. So we are going to have R subscript E multiplied by the total distance from here to here. That is 4.5. 4.5. Then minus what? Minus. Okay, we are at this point. So minus 40 multiplied by the total length here. I'm going to have the total length here is 4.5, then 5. So it's going to be minus 40 multiplied by what? 5. All right. Then we are going to have minus 50 multiplied by what? Minus 50 multiplied by the total distance, that is 3. Multiplied by 3. All right. So don't forget that we have a moment here going anti-clockwise. Anti-clockwise moment and an upward force produce a what? Anti-clockwise moment. So upward force positive, anti-clockwise moment 2 positive. All right, so it's going to be what? Plus 100. All right. All right. So if we take the moment about point B, that is what we are going to have. All right, but don't forget that if we still stand at point B here, we are still having a uniform distributed load here, which we already converted to a point load here by multiplying by what? By the length it covers. You understand? So now this one is going to be 20 multiplied by what? 0.5. Then you are going to multiply by what? By the distance. It's going to cover what? 0.5 divided by 2 distance. All right. So, and then don't forget that here, if we have a point load here, it's going to be going in this direction. That is, it's going to be going in the what? Anti-clockwise direction. This same with this what? Same with this moment that we have here. All right, so that is going to be what? Plus, that is 20 times 0.5. 20 times 0.5 is 10, right? 10. Then we multiply that by the distance it's going to cover. It's going to add at half of the center to this point. So 0.5 divided by 2. 0.5 divided by 2. All right. So here we are going to have this to be R subscript E, that is 4.5 R subscript E. Oh yeah, will be equals to 0. All right. So now here we are going to have this to be equals to, okay, before equals to, let's do a simplification. Minus 40 times 5, that is minus 200, minus 150, and then plus 100, plus 100, then plus 2 here 1, 2 here is 5, right? So it's going to be 5 multiplied by 0.5. 5 multiplied by 0.5, that is 0.25, which will be equals to 0. All right. So if we do this, we are going to have 4.5 R subscript E. If we sum everything here together, we are going to have this to be minus 350, 450. Then it's going to be minus 450 plus 0.25 equals to what? 0. All right. So if we do minus 450 plus, oh sorry please, minus 350 plus 100 is going to give us minus 250, rather, not 450. All right. So minus 250 now plus 0.25. So if we add this together, we are going to have minus 249.75. All right. So we are going to have 4.5 R subscript E minus 249.75 equals to what? 0. All right. So if we move this to the other side, I'm going to have 4.5 R subscript E to be equals to 249.75. So if we divide both sides by 4.5, so this will go with this, then R subscript E will be equals to, we divide this by this, you are going to have 55. So we are going to have 55 kilonewton. All right. But don't forget, from equation 1, we already have RB plus RE to be equals to 100. So it means that our RB there, RB will be equals to 100 minus 55, which is going to be equals to what? 45. Yes, which is going to be equals to 45 kilonewton. All right. So that is our ROB. Now that we know the reaction and the support, now we can now go for the calculation of the what? Of our shear. We can now go for the calculation for shear forces. All right. So let's start with the shear force calculation. All right, so we'll be starting with the shear force at point F. So the shear force at point F. All right, the shear force at point F. If you stand at point F, we only have one force, which is nothing but what? 40. But don't forget, upward force positive, downward force negative. So we are going to have this to be what? Minus 40 kilonewton. All right, so the next one we are going to stand at what? Point E. So the shear force at point E will be equals to, so at point E we have one force, that is upward force, then we have another downward force to our right. So here it's going to be what? 55 minus 40. 55 minus 40, which is what? 15 kilonewton. All right. So now let's go for the shear force at D. The shear force at point D will be equals to, so at point D, from point D to our right, we have three forces. So we are going to have 55 minus 40 minus 50. So that is going to give us what? So this is going to give us 55 minus 90, right? That is going to give us 35. No, minus 35 kilonewton. All right. All right. I think I'm right. All right. So now we therefore go for we don't have any shear force at point C, so we leave that. We only have a couple. That is, we only have moments. So we can go for point B now. So the shear force at point B. All right, the shear force at point B now is going to be 55 minus 40 minus 50, then plus this reaction at the support here. So we are going to have that to be minus, that is 55 minus 40 minus 50. Then if we add ROB, and our ROB is nothing but what? ROB is nothing but 45, right? ROB is 45 plus 45. So that is going to give us what? So if we do this, we are going to have this to be 55 plus 45, that is 95. So if we do this, we are going to have this to be, if we do this, we are going to have this to be what? 10 kilonewton, right? All right, 10 kilonewton. All right. So now the next one, we are going to calculate the shear force at point A. So the shear force at point A will be the same thing. Will be the same. Oh no, can't be the same, because we are going to have a point load here. All right. Cannot. I don't know. I don't think so. Let's calculate it. All right. We are going to have minus that is 55 minus 40 minus 50. Okay. Then if we subtract that, if we had that upward force, that is reaction B, and the reaction B is plus 45. All right. So now, and we have a uniform distributed load, which we are going to convert to a point load. So if we convert to a point load, we are going to have it to be what? Downward, which is going to become negative 20 times 0.5. So 20 times 0.5 is going to be what? That is minus 10, right? So this will be equals to, all right. So if we do this, this is 100, right? Yes, I think we are going to have 0. So this is 0. All right, this is 0. Yes, that's correct. All right, so now the next one is the bending moment calculation. All right, bending moments. All right, this, let me feel this. So we are going to be starting with the bending moment at point F, and the bending moment at point F is what? 0, because at point F to our right, we don't have okay, sorry, we have distance. Yes, you can get this, can easily confuse us, so I need to explain this to us. All right. You know, if we are taking moment about point F, the moment at point F himself must be what? 0, right? And if you look at point F, we have a force on it, which is what? 40. You understand? Each time we are taking our moment about a point, we consider our right hand side. We are taking the moment irrespective of the force and the distance to the what? To the side. And if you look at this side, we don't have any force. Do you understand? We only have distance. You understand? So don't go and make mistake and say 40 multiplied by what? 0.5. That's not correct, please. All right. So now we can therefore go for the moment about point what? Point E. Any moment about what? E. So this will be equals to, now, if we stand at E now, you can see there's a force here now, then we'll use to multiply the distance. All right. So now, but we are having a downward force here. So, and don't forget, upward force is positive, downward force is still what? Negative. So we are going to have this to be what? Minus 40 multiplied by what? Multiplied by 0.5. So this is going to give us what? Minus 20 kilonewton meter. All right. So now the next one is point D. So bending moment at point D. All right. The bending moment at point D. If we stand at point D now, the total distance from this point to this point, the total distance from this point to this point is that is 2, right? So we are going to have, and we have an upward force here, that is 55 multiplied by what? 1.5. 55 multiplied by 1.5 minus what? Minus 40 multiplied by what? Multiplied by 2. 40 multiplied by 2. So this is going to be equals to what? 55 times 1.5 minus 40 times 2. That's going to give us, it's going to give us 2 point, nothing but 2.5 kilonewton meter. All right. So now then we move to point C. So when you get to point C, you have to be very, very careful, because we have two moments there. Bending moment at point C will be equals to, the first bending moment at point C is this. If you start at point C, we are going to have 55 multiplied by the total distance, that is 3.5. 55 multiplied by what? 3.5. Then minus, if you stand at point C, we are going to have this 40. 40 multiplied by what? The total distance, and the total distance is that is 3.5 plus this, you are going to have 4. So it's going to be 4. So 40 minus 40 multiplied by 4. All right. So now we still have a force here, which is what? Point D. So this is going to be what? Minus 50 multiplied by what? Multiplied by 2. Minus 50 multiplied by 2. All right. Then now we now have a what? We now have this force, right? All right. If you look at this force here is producing a what? It's going to be what? Positive, because we said an upward force is going to give us what? It's going to give us an anti-clockwise moment. And when we say our upward force is positive, it means anti-clockwise moment too is going to be what? Positive. So this 100 is going to be what? Plus 100. All right. So if you do this, if we say 55 multiplied by 3.5 minus 40 multiplied by 4 minus 100 multiplied by 2, we are going to have 67.5. I'm going to have 67.5. Is that minus 67.5? So we are going to, since this one is negative, that is 160, 100. That is 160, 100, that is negative 260. So this is going to be, yes, it's going to be what? Minus. So we are going to have minus 67.5. All right, so plus 100. All right. So if you add that now, you are going to have this to be what? 32.5, if I'm correct. Yes. 100 minus 67. Then half. All right. So that is 32.5. All right. So now, okay, we are going to put the unit. So we are going to have kilonewton meter. All right. So now, the next one is the bending moment at what? At point C. The bending moment at point, at point B. Bending moment at point B. All right. So the bending moment at point B. All right. Instead of us taking the moment from this side to this side, we can just decide to take the moment from this side, because we know that clockwise moment will be equals to what? Anti-clockwise moment. I don't know if you still recall from your physics. If we have this side, we are taking moment about point B. If I take this moment like this, it's also the same thing of me taking it in this way. You understand? Clockwise moment will be equals to what? Anti-clockwise moment. All right, you can try that. So now here, don't forget we are saying our upward force is what? Downward. And if you take, if you convert this one to a point load, you are going to have it to be what? 10. And that 10 is going to act at what? Half of what? This what? This line. So it's going to be what? 10 multiplied by what? Is 0. Minus 10 multiplied by what? Is 0. What? 0.5 divided by what? By 2. So we are going to have this to be minus because of the people that some people that will still don't understand this. You convert this to a point load, that is 20 times 0.5. All right. So now it's acting at what distance? It's acting at half of the distance. So from the center to this B side, we are going to have it to be multiplied by 0.5 divided by what? By 2. So I hope this is well simplified now. So this is going to be equals to minus 20 multiplied by this. That is minus 10. 2 can go in 10. That is 5. So 5 multiplied by 0.5. That is minus 0.25. Is it minus 2.5? All right, sorry, there's a little mistake here. Sorry. If we have 10 here, 2 here, 1, 2 here, 2 in 10, that is 5. Then 5 times 0.5. 0.5 is the same thing as 5 over 10, right? So 5 times 5 over 10, that is 25 over 10. And 25 divided by 10 is 2.5. We are going to have minus 2.5 kilonewton meter. All right. So again, you can try. If you don't want to do that, you can stand at this point, then you still take the moment towards this side. We still arrive at the same answer. So that is going to be what? I'm going to have 55 multiplied by the total distance, which is the total distance is nothing but what? 1, 2, that is 3, that is 4.5, right? Let me just outline it here for you. So it's going to be 55 multiplied by what? 4.5. All right. So we're going to have 4.5. All right. So now, then here we are going to have minus 40. 40 multiplied by the total distance. Total distance is 4 point, but that is 5. That is minus 40. Minus 40 times 5. All right. So again, if we stand here, we have first at D. So 50 times the total distance. That is 50 times minus 3. Minus 50 times 3. All right. So don't forget, we now have, all right, forget that we have this just, all right. So we said something the other time that upward force is positive, and our upward force is going to give us what? An anti-clockwise moment. So it means that if we have an upward force to be positive, anti-clockwise moment too will be what? Positive. So we are going to add 100 here. So if you press this value from your calculator, if you don't want to take your moment from this point to this point, you can still stand there and take your moment. So if you do that, you are going to have this. So if you add this together and you multiply, you are still going to arrive at what? Minus 2.5. Yes. All right. Yes, you are still going to arrive at minus 2.5. All right. So now we are done with all the shear force and bending moment calculation. So the next thing is to draw the diagram. All right. So and for us to draw the diagram, we need to trace all the line downward. We now need to draw the reference line for our shear force. Reference line for our shear force. All right. All right. And the reference line for our bending moment. All right. All right. So this is it. So here we are going to have here to be 0. Here will be 0. Here is 0. And here will also be what? 0. All right. So you may want to ask that why is it that we did not calculate the bending moment at point A and at this point too? Let's call this point G. I think I will meet that point. So the bending moment at this free end, this is an overhanging beam. Is that clear? So the bending moment at this free end is going to be what? 0. Is that clear? So let's just put it there. The bending moment at point A will be 0. If you notice, you are going to observe that when I was calculating my bending moment, we did not calculate the bending moment of this point because this is an overhanging beam. So the bending moment at the end of an overhanging beam is what? 0. That's why the bending moment at point G is what? 0, and the bending moment at point A is also what? 0. So we are going to be drawing the shear force diagram and the bending moment diagram. All right. So we have drawn the reference line, and here is the reference line of my shear force diagram. This one will be the reference line for my what? Bending moment diagram. All right. So now at point G, we said our shear force is what? 0 there. So we don't have anything there. All right. So we move to F. The shear force at F is what? Negative 40. So let's put our here to be what? Negative 40. Let's make this point here to be 40. All right. So we are going to join this point to this point. All right. So now between F and E, we don't have any other load. So it's going to be a constant line. All right. So between our shear force at E is what? 15. So we are going to go from this point to the positive side. Let's go for 15. All right. So let's make this point here to be our 15. All right, so these are 15 here. 15. All right. So between E and D, we don't have any other load. It's going to be a constant line. All right. So, and then at point D, our shear force at point D is negative 35. All right. So we are going to come down negative 35. So if from here to here is negative 40, so our 35 should be somewhere around here. So let's just draw this point down. Let's make this point to be our 35. So we are going to have here to be our negative 35. All right. Between D and B direct, we don't have any load. So we are going to have a constant line here. So we are going to have a constant line. All right. So the shear force at point B is what? 10. So we are going to go up 10. So from here to here is 15. So it means our 10. Let's make here to be our 10. It means we are going to have 10 here. All right. So we are going to have 10 here. All right. So now, and the shear force at point A is what? 0, right? So now it means, and then we have a uniform distributed load. So we are going to draw an inclined line from this point down to this point. So we are going to go down here. All right. So here is positive. Here is negative. And here is positive as well. We go in this direction. And then here is negative. All right. Let's just shade this so that avoid confusion. All right. Yeah. All right. Good. All right. So we're going to have this. All right. So this is our shear force diagram. All right. So let's go for the bending moment now. So for the bending moment, and we have a negative 20, 2.5, and negative 20, 2.5. We have a negative 67. All right. Please, I will need to bring this line down. Let's bring this line down a little bit. Let it come down a little bit. All right. So here we are going to have 0 here. I'm going to have 0 here. All right. So the bending moment at point G is 0. All right. The bending moment at point F is also 0. Okay. And the bending moment at point E is what? Negative 20. All right. So we are going to have our, let's have our negative 20 here. Negative 20. All right. So we are going to be using an inclined line to join this point to this point here. All right. All right. So, and if you look at point D, the bending moment at point D is what? 2.5. All right. So it means we are going to go up 2.5 from this point. Then we are going to go to 2.5 because the bending moment at point, oh, I'm coming. The bending moment at point E is 20. So we'll come down here. And then here we have our D to be what? Okay, this less than is our D. All right. So which is what? 2.5. So we are going to have 2.5 somewhere around here. I'm going to have 2.5 here. Let's have our 2.5 here. All right. So, and let's put a point here. All right, so we are going to be using an inclined line again to join the 2 points. All right. You have to be careful dealing with this question, somehow technical. All right. So, and then we are on point D, right? So now from point D, we are moving to point C, and we have to be careful here as well. The bend moment at point C is 2. The first one is when you move, when you are on point C and you go, that is 40 multiplied by total distance minus ROE, which is 55 times this minus 40 times this minus 50 times this, and this is everything that we have here. It's giving us what? Minus 67.5. That is the first moment there. So we are going to go down to what? 67.5 on our what? Point C. So let's make this one here to be our what? 67.5. So let's make this to be our 67.5. Right, since it is the only yes. So let's make this to be what? Minus 67.5. All right. So we are going to be connecting this point with this point here. So we are going to have here to be what? Minus 67.5. All right. So now we now have this 100. We now have another moment here, which is what? 100. I can also call that a couple, right? All right. So when we now add the effect now to what? Minus 67.5 now. If we add that together now, you are going to get 32.5. It means the bending moment there changes from what? Minus 67.5 to what? To what? To 32.5. So we are going to go from this negative side to what? 32.5. So here we said here is what? 2.5. So definitely 32.5 must be above 2.5. So let's make this point here to be our 32.5. So let me put it down here. I don't want it to go and fall the same line with this. Minus 32.5. All right. 32.5. All right. So we are going to draw a straight line here. All right. So this is 32.5 at C. All right. So we are now going to B now. So the bend moment at point B now is what? Negative 2.5. All right. So if from here to here is what? 20. So now it means on our B, our negative 2.5 will be somewhere around here. Negative 2.5. Let's put it here. All right. So we are going to connect this point here with an inclined line again. All right. All right. So that's it. So now, from this negative 2.5, we now have our bend moment at A to be what? 0. All right. So we are now going to connect this point here to what? To 0. All right. Sorry, please. Because we have a uniform distributed load here. So we are going to have a parabolic curve. Sorry. Thanks to Tutor Japheth. All right. So now we are going to have a parabolic curve here. Don't know how I'm going to draw this because I'm not good with left hand. Okay, let me just try. Let's try it. All right. All right. So it's because we are just trying to manage our space. All right. So here we are going to have a negative part here. This place will be negative. This place will be positive. This place will be negative. This place will be positive. And then this place is going to be what? Negative. All right. So can shade. Right. All right. All right. So, all right. All right. So that's it. So this is our bending moment diagram. I don't know where to put that. All right. Let's just clean this side. Let's just clean this side. So these are bending moment diagram. All right. So you can see the question is somehow technical. That is why it is a gate question. So, and I hope we have simplified this concept clear to us. So we would love to know that in the comment section. So you can just drop a comment. Let's see how far we are going with this course. Thanks.